Question 10. Find the exact volume generated when the shaded region is rotated through 360 degrees about the x-axis. So when you see these kind of questions, ignore the rest of the graph. You know your shaded region is this, right? Ignore this part of the graph. You don't need it. So when we rotate it about the x-axis, you're rotating the whole thing. Okay, you're rotating the whole thing about the x-axis. But that's not what we want. We only want this part, right? So, but that's not how the equation works. We can't just chop off this part and calculate this part in one equation. So, what you need to do is, when you use the equation, you're going to get this value. The equation is just the normal one, so it's pi. It's your pi, and this is your y. That's your equation, and you're just squaring it. It's like pi r squared. So you only use the y equation when it's asking you to rotate about the x-axis. However, if they're asking you to rotate about the y-axis, you have to convert y. Let's say your equation is 1 minus 2x. You have to convert it to make y the subject. So that will give you. You have to convert it to make x the subject, sorry. So that will give you y minus 1 over negative 2, and you sub that in. But in this case, we're asked for the x-axis, so we can just straight away plug in your y equation. So that's what I did. You're given the y equation, I substituted it in there, and then I integrated it. So how I integrated it, I moved this up, and I obviously have to make it negative. I moved it up just because it's easier for me to see. So from there, what you need to do is you just plus 1. Then when you divide by the differentiation of your x value, which is 2. And you have to divide by your final value, which is 3. Okay, so that's how I integrated it. I got my value, which is 7 pi over 3. But once again, remember, this is your value. 7 pi over 3 is the whole volume of this. However, we only want this, right? So how do you get rid of this part? Well, it's pretty simple. You have this, you minus this to get this. So that's what you do. If you rotate this, you're rotating a cylinder. So you can use the volume of a cylinder formula, and this is your radius. Because when you rotate it around, it's going to be like that. Okay, so this is your radius, okay, your r, and this is your height. Okay, this is your height, which is 3 over 2 minus 1, you get half. So then you get the volume, or you could just find the volume of that small square piece by integrating again, and this time we know this equation is y equals to 1 because it's just a straight line like this, you see. So you just substitute you don't substitute, you just put in y equals to 1, that's your equation, you put it into this formula, and you integrate it and get x, and then you find the equation from there. You find the answer from there. So the volume of revolution would therefore just be, remember this minus this equals your answer. So I got this minus pi over 2, and get your final answer, 11 pi over 6. So for B, we're trying to find the area of a triangle that is formed from the tangent to the curve at B, the normal to the curve at B, and the x-axis. So what this is, tangent, this is your normal, looks something like that. This is your tangent, and your x-axis will be here. So we're trying to find the area of this triangle. Tangent, normal. So what I did was I differentiated the equation to find the gradient of my tangent, because that's how you find it. You have to differentiate your equation to find the dy over dx, and from there you just substitute the x value of the coordinate where the tangent is, and that over here is b. So my x value will be 3 over 2, and I substituted that into my equation and I got the gradient -2. From there I can find the equation of my tangent, which is you just use the equation y minus y value equals to your gradient y minus y1 equals mx minus x1. So my y is my 1, my x is my 3 over 2. And then from there I want to find the coordinate where my tangent has crossed into the x-axis, and that is over here. And as you can see, when the tangent crosses x-axis, your y is equals to 0. So I found the equation. I just need to substitute y as 0, and then I found 2, 0. So now we know this is 2. And then since your gradient of your normal is equals to -1 divided the gradient of the tangent, which is what I wrote over here, you find the gradient of your normal by dividing your gradient of your tangent with, you divide -1 by the gradient of your tangent, got half, found the equation of my normal, and therefore I know that the normal crosses at -half over 0. Okay, so our triangle is looking like this now, right? So -half, we know this is a 90 degrees because it's a tangent and a normal, and therefore it's a right angle triangle. You can use half times base times height, or you could just, to make life easier, I'm separating this triangle into 2 parts. Again, right angles, but have my base here, my height here, and I have my base here, my height here, and then another one is a base here and a height here. So that's what I did. Over here, this is your 1. So this distance is 1, that's my base. This part, this is my 3 over 2, and over here is 1. So this is my base. This is my base, and this is my height. So this is my base, height. See, the height remains the same. My base just differs a little bit. So this distance is 2. This distance is 2 minus 3 over 2. So that's what I did here. 2 and 2 minus 3 over 2. You add it together and you get the answer 5 over 4. Question 11, the equation of a curve is such that dy over dx is equals to this, and then a is positive constant. The curve has a stationary point at a equals -15. You see stationary point, you immediately know dy over dx equals to 0. Just always remember that. So that's what I did. I equated dy over dx equals to 0, and when x equals to a, that's what I substituted x for, because it says here x equals to a. So then you can just simplify it, factorize it out, and you get a equals to 0, a equals to 4. However, you reject a equals to 0 because you want a positive constant. So that's why you get a equals to 4. Determine the nature of the stationary point. You see nature and you see stationary point, you either have to find dy over dx and then find d squared y over dx squared. But over here we are already given dy over dx. So now we just need to find d squared y over dx squared. So that's what I did. I differentiated dy over dx, substitute x equals to 4 because that's what I found earlier, and you get 18. This is a positive value, so which is larger than 0, so it's a minimum.